Hello everyone, welcome back to my channel. It's been a long time. Today's session is on the white matter of cerebellum. So I have already done 3 sessions on cerebellum, the cerebellar cortex, how the nuclei are arranged. So please do watch those sessions so that you will get a continuity to watch this session. Okay, now coming to the white matter of cerebellum, we know that there are mainly 3 types of white matter fibers within the cerebellum. One is called intrinsic. By the word meaning intrinsic, it is confined to the cerebellum. That means they connect different areas of the same cerebellar hemisphere, or they connect different areas between the 2 cerebellar hemispheres. So these fibers are confined to the cerebellum. The next group is called efferent fiber, and the third variety is efferent fibers. So in this session, I will be concentrating more on the efferent fibers. So what do you mean by efferent fibers? Efferent fibers are the fibers which are reaching to the cerebellum from different parts of the central nervous system. And what do you mean by efferent fibers? They are the fibers which are leaving the cerebellum and going to different parts of the central nervous system. So that means efferent and efferent fibers connect cerebellum with different parts of the central nervous system. So let's see the efferent fibers. So the efferent fibers, the source of efferent fibers can be from 4 main sources. That is, it can come from the cerebrum, it can come from the spinal cord, it can come from the vestibular apparatus, or the 4th option is it can come from the midbrain. So let's see one by one. If it is coming from the cerebrum, we have 3 options. One set comes through the cortico-pontocerebellar pathway. The next set comes through the cerebro-olivocerebellar tracts, and the third option is from the cerebrum through the reticular formation and then to the cerebellum, that is cerebro-reticulocerebellar. So these are the 3 options through which the cerebrum, the fibers from the cerebrum reach the cerebellum: cortico-pontocerebellar, cerebro-olivocerebellar and cerebro-reticulocerebellar fibers. Now coming to the spinal cord. How are the fibers from the spinal cord reaching the cerebellum? Again, there are 3 options. It can come through the anterior spinocerebellar pathway. Then the next option is posterior spinocerebellar, and the third option is cuneocerebellar. So these are the fibers connecting the spinal cord to the cerebellum. The efferent fibers connecting the spinal cord with the cerebellum. Now coming to the third option, that is the vestibular apparatus. The vestibular apparatus means it includes the utricle, the saccule and the semicircular canals. So from the vestibular apparatus, the fibers will reach the cerebellum either directly or sometimes it will relay in the vestibular nucleus, and then from there it will be projected into the cerebellum. Now coming to the 4th option, it is midbrain. And from the midbrain, there are mainly 2 sources. It can come either from the red nucleus of the midbrain or from the tectum. So these are the 4 options from which we can receive the efferent fibers to the cerebellum. So we usually say that it is the spinocerebellar tract which is considered as the major sensory pathway to the cerebellum. And we know it is actually the subconscious proprioception. It is not at all concerned with the conscious proprioception, but it is concerned with the subconscious proprioception. And these efferent fibers, we know the cerebellum is connected to the different parts of the brainstem through 3 cerebellar peduncles: the superior, middle and inferior cerebellar peduncles. And coming to the efferent fibers, they enter the cerebellum through 2 cerebellar peduncles, that is the inferior and middle cerebellar peduncles. Now coming to the different types of fibers. The fibers are actually classified as 2 types. One is called the climbing fibers and the other type is called mossy fibers. So what do you mean? What is the main difference between the climbing fibers and mossy fibers? The climbing fibers are the fibers which are coming from the inferior olivary nucleus or accessory olivary nucleus, and these fibers are called olivocerebellar fibers and para-olivocerebellar fibers respectively. So these are the fibers coming from the inferior olivary nucleus and accessory olivary nucleus. So obviously all the rest of the fibers, all the rest of the efferent fibers belong to the mossy fibers, and they are actually forming the main bulk of the efferent fibers. Now let's see one by one how are these controlling the cerebellum. So the climbing fibers, we will see the climbing fibers first. These actually give collateral pathway to the intracerebellar nuclei. So they are having connections to the intracerebellar nucleus through the collateral branches, and they are excitatory. Of course, the climbing and mossy fibers are generally excitatory in function. Now, it is also synapsing with a single Purkinje cell. Okay, and what is the importance of this? It is having a monosynaptic connection with the Purkinje cell. So, one climbing fiber will be influencing only one Purkinje cell, and it is actually again an excitatory type of synapse. Now, when we come to the mossy fibers, we can see that the mossy fibers, they ascend and they end in 30 to 40 terminal expansions. And these 30 to 40 terminal expansions, you call it as a rosette. So one expansion is known as a rosette. And this rosette will be synapsing with the granule cell and with the Golgi cell. It is the dendrite of the granule cell and it is the axon of the Golgi cell of the cerebellar cortex. And it will be covered by a neuroglial capsule, and altogether it forms the cerebellar glomerulus. I will be discussing about the details of the cerebellar glomerulus soon. So let's see the components of the cerebellar glomerulus. It is made up of one rosette out of the 30 to 40 rosette of a single mossy fiber. Then you have the axons of the Golgi cell and you have the dendrites of the granule cell. So it is said that one mossy fiber will be having 30 to 40 rosette, and each rosette will be actually synapsing with almost 15 granule cells. Okay, with the dendrites of the 15 granule cells. And each granule cell is actually having an area about 2 to 3 millimeters in the cerebellar cortex. And in this 2 to 3 millimeter area, you have almost 500 Purkinje cells arranged. So you can see that one mossy fiber through 30 to 40 rosette will be influencing 450 granule cells, because each rosette will be having a connection with 15 granule cells. Okay, so around 450 granule cells, and each granule cell in an area of 2 to 3 millimeters will be influencing again 450 to 500 Purkinje cells. So overall, one mossy fiber will be influencing thousands of Purkinje cells, whereas when we compare it with climbing fibers, one climbing fiber will be influencing just a single Purkinje cell. So that is the main difference between climbing fiber and mossy fiber. Now I would like to discuss something in detail about the cerebellar glomerulus. So cerebellar glomerulus, we already mentioned that it is made up of three main components. One is rosette, that is the terminal expansion of the mossy fiber. 30 to 40 rosette will be there for one mossy fiber. So we will consider one cerebellar glomerulus. So in the center there will be one rosette. And immediately next to that, we can see that something is enveloping the rosette, and they are actually the dendrites. The dendrites of the granule cell, they will be actually enveloping the rosette. And outer to it, you have the axons of Golgi cell. So rosette in the center, then you have the envelope by the dendrites of the granule cell, and outer to it, you have the axons of the Golgi cell, and outermost, the entire thing is actually capsulated by neuroglial cells which belong to the Bergmann glial cell. So the neuroglial cell responsible for the formation of the neuroglial capsule of the cerebellar glomerulus is Bergmann glial cell. So it is said that there are mainly three types of astrocytes in the cerebellar cortex, and out of these three types, one is Bergmann glial cell, and the others being the granule type of astrocyte and the fibrous type of astrocyte. So Bergmann glial cell is one type of astrocyte. And here we need to find which are the presynaptic elements and which are the postsynaptic elements. So when we consider a synapse, we know that we have the information coming through the axons. It forms a synapse and it is carried from that synapse by the dendrite. So the dendritic portion will be considered as the postsynaptic element and the axonal portion will be considered as the presynaptic element. So in this cerebellar glomerulus, which are the endings or which are the axon counterparts? One is the rosette, that is the axons of the mossy fibers, the terminal ends. And the other one is the axons of the Golgi cells. So these two are considered as the presynaptic elements, and the one which are leaving, that is the dendrites. The dendrites are from the granule cells. So the dendrites of the granule cells are considered as the postsynaptic element. Hope this idea is clear. So in a cerebellar glomerulus, you have the two sets of axons, one through the rosette and one through the Golgi cell, and you have the dendrites that is through the granule cell. So the presynaptic element and postsynaptic element. Presynaptic element being the rosette and the axons of the Golgi cell, and postsynaptic element being the dendrites of the granule cell. So this is what is meant by cerebellar glomerulus. So hope this idea is clear for you. So once again, the white matter of cerebellum, we know there are mainly three types: the intrinsic fibers which are confined to the cerebellum, then you have the efferent fibers which are reaching the cerebellum from different parts of the central nervous system through the inferior and middle cerebellar peduncle, and you have the efferent fibers which are leaving the cerebellum. I will be taking the details of this in the next session, and they will be passing through the cerebellar peduncles, especially the superior cerebellar peduncle, and of course some will be leaving through the inferior cerebellar peduncle as well to the different parts of the central nervous system. And the importance is there are two types, climbing and mossy fibers. Mossy fibers form the main bulk. Both climbing and mossy fibers are excitatory in function. The difference is climbing will be stimulating one Purkinje cell, whereas mossy will be influencing thousands of, one single mossy fiber will be influencing thousands of Purkinje cells. Thanks for watching. Please do leave your comments in the comment section so that I will be motivated to do more and more sessions. Thank you.